one of the meanings of sigma is a standard deviation, a measure of variation of the process variable. Another important meaning of sigma is a statistical measure of ability or capability of the process to meet customer requirements. And last but not least, a management philosophy based on the vision of processes and their measures from a purely client point of view. It is a constant improvement of one's performance, the pursuit of the optimum level. The Six Sigma methodology, as already said, is to reduce the variation of the process result and optimize the input variables of the process, which significantly affects this variation and the position of the process with respect to the client's requirements. Actually, there are two types of optimization. The first one is the process centering to make the studied mean value reach the set target, or the target required by the client. The second one is the span reduction of the span. That is, distribution of process data. In other words, we narrow the scope of the process, whose mean value, in many cases, meets the customer's requirements. How to proceed in order to optimize the span and move the mean value? This is what DMAIC algorithm stands for. The name comes from the first letters of the successive phases of the project. D means define, M, measure, A, analyze, I, improve, C, control. Each phrase will be further analyzed. What we deal with is input data. In Six Sigma, they are professionally called factors, and output data, or the results of our process. During the define phase, we create a picture of the current process, its imperfections from the point of view of the customer. We collect data, develop the project charter, which contains such details as the business case, the problem, the purpose of the project. An important part is also to build up the project team, the project scope and timeline. Placing in the project charter potential savings from the project provides the champion with information about the validity of the project launch. The champion is a person who, acting from the board or management level, on the one hand manages the process he or she is responsible for, and on the other hand, has at his or her disposal the necessary means such as human resources, finances, and other things. To sum up, in the first phase, we define what poses the problems, which state would satisfy us, what information tells us about it. In this phase, the data that we analyze are the process output, or its result. The measure phase is primarily intended to provide us with an answer whether the data we have collected from our process, presented in a graphics and which we will analyze, are reliable. Whether they are sufficient for us to draw conclusions from them. To achieve this, one of the important elements of the measure phase is to validate the measurement system, commonly known as MSA. This tool is supposed to give us the answer about the data reliability. In this phase, we also rely solely on the process results. Now it's time for the analyze phase. This is the first time when you should take a look at the left side of our process, namely factors or inputs. In this phase, we collect information about the input variables generating the result. In other words, this is the moment when we look at the elements that control our process. Some of them are called uncontrollable factors. Uncontrollable factors are those factors which we have no influence on. The others can be varied, leading to a change in the process results. One example would be the reduction of time needed to cover the distance of 100 kilometers, where the uncontrollable factor is the weather or an unexpected traffic jam. Having identified potential inputs, it's time to analyze them and determine the significant variables. Significant variables are those that can be adjusted and whose change will significantly affect the process result. In our example, the significant variable will be the kind of way we choose. If we take the highway, we should significantly reduce the travel time as compared to on a local road. It is these factors that will be covered in the next step of the improve phase. There, we will determine the optimum position of the input variables to achieve the purpose of the project and meet customer requirements. Input variables can be improved with several available methods: random sampling, or improving each subsequent factor, or planning the design of experiment. This term will be explained in the part Improve. The last phase of the project is Control. The purpose of this phase is to analyze the risk of losing the achieved purpose, a new level of our process. Implement the measures preventing the occurrence of the problem. Use the process monitoring system. What remains is to create new standards, put them into effect, to train people directly and indirectly involved in the process, and create the measurement and control method after the optimization so as to maintain the implemented measures over a long time. Having obtained satisfactory results, our improved process should be implemented, as far as possible, on a larger scale by copying the solution to analogous processes. Thank you for your attention, and we'll see you in the next episode.